1, 2, 3.
This podcast is brought to you by Red Engineering and Design, the engineering firm that provides practical solutions to complex structural problems. Concrete footings under columns are used to transfer building loads to the ground below. As the load moves from the column to the footing, it tends to spread out. And the size and thickness of the footing, therefore, depends greatly on the type of soil supporting it. A stiff, clayey soil may support a higher load than a sandy soil, but each type can cause different behavior in the footing. Two conditions must be considered in the column footing regardless of its shape. First is one-way or beam shear. This behavior is similar to how a wall sits on a continuous footing. The soil pushes up and can cause bending along the bottom. Therefore, steel reinforcement is added to the footing to help resist this bending. The second condition is two-way or punching shear. This considers when a column load is spread out over the entire footprint, and this creates diagonal tension on all four sides and may cause the column to punch out of the bottom and create a truncated pyramid shape of concrete. Again, steel reinforcement is typically added to help resist this force. But what happens when a column is not centered on the footing? As the column gets closer to the edge, the pressure under that edge increases, while the pressure on the other side decreases. When the column gets to within about 1/3 of the way, a negative pressure develops and the footing may lift up as if trying to take a step. This uplift is generally discouraged without some way of anchoring the footing down, but at the same time not exceeding the allowable bearing pressure of the soil below. Follow us at redengineeringdesign.com or brianmosco.com.